And see, when we proceed with the program, there in this class function AR1, you have a function called main, public void main.
Hello.
Okay,
Okay,
and
alle.
you can see the array is being declared. Just ignore the try catch now. Okay, we are not going to discuss all that now. That we will discuss later on. Try and catch, you must have learned in smaller classes. Suppose our program is having some errors. Very easily we can rectify them, because error handling is it's an important aspect of programming. So normally when we write programs, it can generate errors. Okay, so to avoid that, every program which we feel there are errors can be put in a try and catch block. So try and catch, I'm not going to explain here. Just ignore that try block. That is try starting with a curly bracket. It will have a corresponding closing bracket. Immediately you'll have catch. Just ignore that for the time being. So here you have int mark square bracket equal to new int of size. You can see size is already declared there as 5. See how it is being declared. Final int size. Final is a keyword in Java which is used to declare constants. Okay, final is a keyword actually used in Java for declaring constants. Okay, final variable. Final int size equal to 5 means the value of size will become 5. It will store 5, and you can't change this value during the execution of the program. That is the meaning of that. Final keyword you must have heard about. So if there are people who didn't hear that, it is final is just a keyword which is used for declaring constants. So when you write a statement, final int size is equal to 5, size is a constant whose value is 5. Integer constant it is, because the data type is declared there as int. Okay, that is one way of initializing the size of the array. And following statement is int marks is equal to marks square bracket equal to new int of size. Size is 5, so this array marks can store maximum 5 values. Okay, and you can see a loop there, just ignoring the try block. For I is equal to 0, I less than size, I plus size is 5. Then system.out.print enter marks of each student I plus 1, first child, second child, like that, and you're storing there marks of 5. Marks of 0 will store the first child's integer.parseInt buffer name.read line. That is, instead of that, you can use a scanner class like marks of 5 is equal to scanner object. You have a scanner object name dot next int job. Instead of that statement, you can write this. Okay, and it is being displayed. For that also you have a loop. For I is equal to 0, I less than size, I plus plus. This loop control variable, if you want inside the bracket itself, you can declare. Here they have declared about that is at the function level they have declared. Not required to do always like that. You can declare at the loop itself. You can initialize in loop control variable. Okay, I is equal to 0, I less than size, I plus plus. That is how the values are displayed. Each and every location's value is displayed as system.out.println of file. Okay, and you will get something like this. So all those who have systems at home, you can try this program. What you have to ignore here is data input stream. Instead of data input stream, you can use a scanner class, import the package. Okay, then ignore the statement try block. Try, after try you can see the curly bracket close. That is not required. You can start at for I is equal to, or for int I is equal to 0. Okay, then catch also you can just catch nothing they have written in the catch block. Catch exception E opening curly bracket closing. You can ignore that statement full. You can just mark in your textbook, just strike off that. Okay, and you're displaying and see if you're getting the output like this. I hope I'm audible to everybody. Dhyan, you heard whatever I said? Dhyan? Kirtana, can you hear me?
Yes, ma'am.
You heard everything?
Yes.
Kirtana and the audio ko problem undo.
Ma'am, your voice is too low.
Too low, huh? You didn't hear anything. Did you hear, children?
Yes, ma'am. Yes,
Heard.
ma'am.
Then if my audio is low, you should tell me that time. You can just unmute and tell me. Okay. So now you know how to declare a single dimensional array. You also learned how to store values into a single dimensional array and also to display the values in single dimensional array. Hope all this is clear for you. That you have to check at home. Okay. Now you just turn on the page. That figure 15.2. See. Look this. See how memory is allocated. When you are using an array, how does memory allocation take place? That is being explained with the help of that diagram. Before that, you just look at the memory representation of single dimensional array. You can see a character array being declared there. When you're declaring an array, it can be of any type, any data type. It can be of car, it can be of integer, it can be of floating point. So whatever it is, you just specify the data type, array name, square bracket, okay? Then followed by new data type and the size. So any data type you can use, any valid data types can be used. So here in this example, you have a character array, car grade, square bracket equal to new car of size is 8. It's given as 8. And you can see a pictorial representation there. See, so many boxes are drawn there. And see children, a character data type. See, a character data type takes 2 bytes. 2 bytes you have written an assignment on these data types. No? That time you must have learned. Character takes 2 bytes for 2 bytes of storage space. So, as I said, 8 is the maximum size of this particular array called grade. It is of type character. And as I said, continuous memory, free space should be available for allocation. Suppose you just imagine that we have continuous free space is available in memory, and that is why we are able to do allocation. So here in this example, grade is an array which is of type character. So each location will take 2 bytes. Each location will take 2 bytes. Okay, so if the first element is stored at memory address 2000, then second element will be stored at memory address 2002. This is because character data type takes 2 bytes for storage location. Each location takes 2 bytes. Okay, I hope I'm clear. Integer takes 4 bytes. No? Yes. Someone is saying something. Who said that? Children, can you hear? Yes, no? Yeah. Okay. Okay, so each location is taking 2 bytes. So if the 0th element is stored at memory address 2000, then the second element will be stored at, that is the first element will be stored at 2002. The third element will be stored at 2004, memory address 2004. Okay, you know, you have learned the stored value and L value and R value. Location value. Location value is 2000. R value is stored value. So we already discussed each and every memory location has got an address, a unique address, very unique address and Omoro location. In this example, the address is taken as 2000. It can be any other number. Okay. This is just they're showing an example. So suppose if the first element is at memory address 2000, so 2000 and memory address 2001, 2 locations will be reserved for storing the first element. 2000 and 2001 will be stored. That is the first 2 rooms. Okay. Memory locations I told you earlier. Just imagine they are rooms. You can store something in that room. Okay, so memory address 2000 or memory location 2000 and 2001 will be used for storing the first value. Okay, that is grade of 0. Okay, grade of 1 will start at address 2002. So 2002 and 2003 will be used for storing the second element. Okay, the third location starts at 2004 and so on. Look at the last location, grade of 7. Where is it stored? At 2014. So this happens because character takes 2 bytes for each storage location. Suppose it was integer, each location will take 4 bytes. If the first element is at 2000, the second one will be at What can you guess? 2000, 2001, 2002, and 2003 will be storing the first element. Okay, 2004 will onwards will start the second element. Am I clear, children? What I'm saying is clear. Okay, so that diagram is very important. This is how an array looks like. So depending upon the data type of the array, the storage location, that means that many voice, that many um, uh, memory locations will be reserved. So for this array, how many locations? Maximum 8 locations will be reserved. Reserved, you know the meaning of reserving. That means that much of space will be allocated or reserved for this particular variable called as grade. Like that, you can declare any type of array. If it is an integer, array, the keyword will be int. Int array name square bracket equal to new int of size. If it is a floating point array, it will be float data type square float variable name square bracket equal to new float of size. Size will be given in square bracket. So size should be determined well in advance, that is before execution of the program. So whenever you define the size, that many locations will be reserved. So these are the basic things. And array indices starts at 0. The first element will be stored at index value 0. So accessing of elements is very easy. Storage also is very easy. We can use a single loop for storing values. We can also use single loop for accessing each and every location. So for accessing locations, we always have to specify the index value. Which index? See this example, it's a grade of 0. Grade of 0 is storing the first element. Grade of 1 will be storing the second element and so on. So if you specify system.out.println grade of 0, you will get the value which is stored at the 0th location. If you give system.out.println grade of 7, you will get the value which is stored at the last location. I hope I'm clear. Clear now, children?
Yes, sir.
Okay. So don't tell me in the next class you forgot to read the textbook. So read the textbook and you have to understand that. Okay, all these things you can read. Then instead of that, you can see one small example given here. This pointer, finger pointer, you can see. Can you see this? So this is initialization and at the time of declaration. Another way of how to create an array and at the same time initialize the array. See that example, int a square bracket equal to opening curly bracket. See, you can see 1, 2, 3, 4, 5. So in this case, here all these 5 values from 1 to 5 will get stored in an array and the maximum size of the array will be 5 because the number of elements given in the curly bracket will be the size of the array. Suppose we know the values which are to be stored in an array sometimes. Sometimes we have to use direct initialization. Okay, directly the value should be stored into an array instead of reading it through the keyboard. So in that case, we can give it like this if we know the values. So int a square bracket equal to, after that you have the curly bracket, then all the values which you would like to store in this array will be given separated by comma and the semicolon is there. So that statement is read as it is creating an array, integer array A. At the same time, the values are being stored. Initialization of the array also happens. This way we can do for direct initialization. Suppose we don't want values to be stored like this, you can accept through the buffer, you can accept through the scanner class or any other input mechanism. I hope this is clear. So when you give it like this, what is being explained here, the size of the array will be how many elements you are giving in that curly bracket. That will be the size of the array. Here 5 values are given. Okay, so size of this A array will be 5. I hope I'm clear. Clear, no? Dhyan, clear, no? So that also you have to go through. Okay. Then out of bound, we will discuss out of bound 2-dimensional, we will discuss in the next class. So very less, a few topics only I'm taking, very less only I'm taking each day. So don't tell me you are not reading the text. Read your text, prepare the notes, start writing notes, write your own notes, write simple language, write the notes in simple language, like what is an array, what is the need for array, definition for single and double dimensional array, how to declare array. You can start writing the notes so that it becomes thorough. Write and learn, all of you. So thank you, children. We'll stop for today.